In this video, we prove using mathematical induction that 25 to the power n plus 1 minus 24n plus 5734 is divisible by 24 square for n equal to 1, 2, 3, 4 and so on. This question is asked in IIT JEE 2002 main examination. In fact, it is question number 2. Let's do it. As we want to prove by principle of mathematical induction, we need a statement. So we frame the statement, let Pn be the statement 25 to the power n plus 1 minus 24n plus 5735 is divisible by 25 square for n equal to 1, 2, 3, 4 and so on. At this stage, it's just a statement. We are not saying whether it is true or false. However, we need to show that starting point is true. As we want to prove by mathematical induction, we must be able to show that starting point is true and we must be able to obtain some cycle. So P1 is the statement 25 to the power 1 plus 1, that's 2, minus 24 times 25 plus 5735 is divisible by 25. That's equal to, we can take 25 common and 25 minus 24 is just 1. So 25 plus 5735, that's equal to 5760. Observe that 576 is a multiple of 4. 576 equal to 4 times 144 and 4 equal to 2 square. 144 is 12 square. So it is 24 square. So this is equal to 24 square times 10. So definitely a multiple of 24 square. In other words, P1 is true. P1 is true. So we show that starting point is true. Now we will obtain some kind of cycle. In order to prove something, we must assume something. So we assume Pn is true for some n equal to k. So we want to obtain a cycle. So we are assuming Pn is true for some n equal to k. Now we will show that Pn plus 1 is true or Pk plus 1 is true. Then, so we want to write k plus 1 instead of n. So 25 to the power k plus 1 minus 24 times k plus 1 plus 5735. We claim that pk plus 1 is true whenever pk is true. So we write this as 25 times 25 to the power k plus 1 minus 24k minus 24 plus 5735. So we are assuming pk is true. So 25 to the power k plus 1. We got 25 to the power k plus 1, but we got 25 as well. So we write 25 as 1 plus 24. 1 plus 24. 25 to the power k plus 1 we copy as it is. 24 times 25 to the power k plus 1. Okay, we are maintaining same number. 1 plus 24 is 25. Then minus 24k we copy as it is. Plus 5735 we copy as it is. Minus 24 we write it down. As per our induction assumption, pk is true. So this quantity is definitely a multiple of 24 square. How about this one, the left out term? However, 24 times 25 to the power k plus 1 minus 1 equal to 24 times, you see that we can factorize this. We can write it as 25 minus 1 into 25 to the power k plus 25 to the power k minus 1 plus dot 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 plus 25 plus 1. In fact, it is something like 1 plus r square plus dot 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 plus r to the power k times r minus 1 is r to the power k plus 1 minus 1. This is simply a geometric series, which is equal to 24 square and this big sum 25k plus 25 to the power k minus 1 plus dot 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 plus 25 plus 1. So what do we observe? We observe that this quantity is a multiple of 24 square, and this one is also a multiple of 24 square. Multiple of 24 square plus multiple of 24 square is definitely a multiple of 24 square. So 25 to the power k plus 2 minus 24 k plus 1 plus 5735 is a multiple of 24 square. So pk plus 1 is true whenever pk is true. So by principle of mathematical induction, pn is always divisible by 24 square, that is 25 to the power n plus 1, 25 to the power n plus 1 minus 24n plus 5735 is always divisible by 24 square.